This is Note-Taking Guide 6.1 for Math 3 Rational Expressions. So what I'm going to show you to do today is how to simplify, multiply, and divide rational expressions. We want to just remind you that the numerator is the top of the fraction, the denominator is the bottom of the fraction. So when we're talking about fractions here, we can reduce them or simplify them if we can find like terms to cancel or to divide to 1. Here we have a times c and b times c. Well, c divided by c is 1, so they will cancel to just a over b. But on this other side, we have a plus c and b plus c. Because these are added together, they're connected. They're one term here together, connected, and this is another term. Because the c is connected to the a and relies upon the value of a, and c here is connected to b and relies upon the value of b, we cannot cancel this. It's hard to see that cannot sign right there, but they are not equal to that. This has to stay exactly the way that it is. So here on the bottom, the x plus 1 and the x plus 2, they do not cancel. They have to stay exactly the same way they are because they're attached by addition. Here though, the 3 times x attached by multiplication, the 4 times x is attached by multiplication. So I can divide the x divided by x and get 1. So my answer here would just be 3 over 4. On this next one right here, the way that it looks right now, it's attached by addition and I can't cancel anything. But if I take a 2, a greatest common factor of 2 out of the top, and I end up with x plus 2, then the x plus 2 can cancel with the x plus 2 because then this x plus 2 was attached to multiplication to the 2 that was out front. So my answer would just be 2 over 1 here, or just 2. So what we're going to show you to do today is just simplify rational expressions by factoring and canceling what we can cancel. So sometimes it's a little bit confusing though because there's a negative 1 hiding in there. So we're going to look at a couple examples that have some negative 1s. So here, if we're looking at this, we'd have a negative 7 divided by 7, which actually cancels to a negative 1, and then x divided by x, which cancels to 1. So my answer here is just negative 1. The same thing cancels here. The x plus 2's cancel, but I'm left with a 1 on the top, and I'm left with this negative 1 on the bottom. So this cancels to a negative 1. Then on the bottom right here, we never ever want to leave an x as a negative if it's in the front. We want to factor out that negative 1 and see what happens. That will change the sign on the x and change the sign on the 4. Then if you notice, it will cancel with the top. I'd have only 1 left on the top, and 1 divided by negative 1 is a negative 1. So you can look and see if there's a negative 1 kind of hidden in these so that you can kind of cancel it. So here again on the bottom, we want to rewrite that so the x is in front. We always want it in standard form. Then when that x is negative, I want to factor out a negative 1 to see if there's anything that will make it cancel with the top. When I factor out a negative 1, it changes the sign on the x and changes the sign on the 5. Then they'll cancel up top. I have left with 1. 1 divided by negative 1 is a negative 1. So just be really careful to notice when you have that negative 1 hidden in there that you can factor it out. Okay, we're going to skip over the next 2 parts of this note-taking guide. So we're skipping this section and we're skipping this section because it's really just the same thing, finding that negative 1 hidden in there. And we're going to jump right down to these 2 that are down here. Now this first problem, we have 8x cubed y divided by 2xy squared. And I want to write this out just term by term for you to think about it for just a minute. 8 would be 2 times 2 times 2. X cubed is x times x times x, and then I'd have y. On the bottom I'd have 2 times x times y times y. When you write it out that way, it makes it really easy to see that I can cancel one of these 2's to 1. I can cancel a set of x's to 1, and I can cancel a set of y's to 1, so I can see clearly what's left on the top and the bottom. On the top I'm left with 4, and then x squared, and on the bottom I'm left with y. So my answer would be 4x squared divided by y. And then I'm done because nothing else will cancel. On this problem right here, the 7x to the 4th y cubed, let's try to do it without having to write out the other parts of it. So when I do this, I can look at my 7 and 4 and I'd be, 7 and 4 don't reduce or cancel, so I'm going to leave them both there. I have 4 x's on the top and there's none on the bottom to cancel. I have 3 y's on the top and 1 y on the bottom, which means 1 y would cancel and there'd be 2 left on the top. So this would be my solution on that problem. We're going to just keep going on and finish simplifying these by factoring and reducing anything on the top that can cancel with anything on the bottom. So on the top, when I factor this, I have x times x, and then I'm looking for my numbers that will multiply to 6 and add to 5. Those numbers are a positive 3 and a positive 2. Then I'm going to factor the bottom. They have an x in common, so I'll have x plus 3 times x on the bottom. Those x plus 3's cancel. Then I really just rewrite what I have left over. And even though these x's right here look tempting to cancel, I cannot cancel them because they are attached on the top by addition, so we have to leave it alone. Okay, factor, reduce, simplify, that's what we're doing here. So on the top, there's a greatest common factor of x. I'm going to take it out. I'm left with x plus 5. On the bottom, there's a greatest common factor of x, and I'm left with x plus 1. Again, all I did there was factor out my greatest common factor. Now I'm looking for things in common on top that are the same on the bottom. The x's can reduce to 1. And then on the top, nothing can cancel with the bottom, so I'm left with x plus 5 over x. Again, these look tempting to cancel, but they do not because they are attached to another number by addition. All right, again, we're still factoring and canceling what we can. So we're finding on the top two numbers that will multiply to 15, which would be 5 and 3. It would be a negative 5 and a positive 3. On the bottom, I have a difference of squares, so I have x plus 3, x minus 3. And I'm just going to cancel everything that can. So the x plus 3's are gone. I rewrite my answer, x minus 5 over x minus 3. The next one, factor top and bottom. The top is already factored, so we're going to factor the bottom. It's a difference of squares. So it factors to x plus 4, x minus 4. So up here, the x plus 4 cancels with the x plus 4. X plus 4 divided by x plus 4 is 1, which leaves me with a 1 on the top and an x minus 4 on the bottom. So we always have to use that placeholder of 1 on the top when we divide. If there's nothing left up there, it really is a 1 that's left up there. Okay, number 6 is almost the same as number 5, but if you notice, this bottom part is flipped the wrong direction. So we are always going to flip it the right direction, and then when that negative's out front, we're always going to factor out the negative 1. That way, sometimes there's just something that can happen there, like this one then becomes a difference of squares, and I can factor it. The x plus 4 will cancel with the x plus 4 on the top, which leaves me with a 1 on the bottom, a negative 1, and an x minus 4. These will just simply reduce to a negative 1, and then on the bottom, x minus 4. You really don't need to show the parentheses here, but it's okay if you do, so it's your choice whether or not you leave those parentheses there. All right, this is a multiply problem. When we multiply, we're simply just going to multiply top times top and bottom times bottom. But what we're going to do in order to do that is simplify everything we can first. So we'll factor every part of it and then cancel anything that's on the top with anything on the bottom. So this first one right here, I'm going to rewrite it with the 3x squared in the front. So negative 3x squared plus 3x. And I'm going to do that because I can then see that I can factor out a greatest common factor out of it before I do anything else. So it has a negative 3x in common. And then I would have an x minus 1 right here. Find your numbers down here that will multiply to a negative 5 and add to a positive 4. So how about a positive 5 and a negative 1? Two numbers that will multiply to a negative 20 and add to 1 would be 5 and 4, positive 5, negative 4. And then down here you still just have the 3x. Sometimes I just like to rewrite it so I can see what I'm doing. X plus 5 cancels with x plus 5. X minus 1 cancels with x minus 1. 3x cancels with a negative 3x to be a negative 1. So on top I have a negative 1 and an x minus 4, and there's nothing left on the bottom. So I could leave my answer like this, or I could multiply that negative 1 back through to have a negative x plus 4. Either of those answers would be okay. All right, this next set of problems again is multiply. So we're going to multiply by factoring the tops and bottoms and canceling anything on the top with anything on the bottom. So I'm looking for numbers that will multiply to 3 and add to 4, which would be 3 and 1, both being positive. I'm looking for numbers here that will multiply to -10 and add to -3, so a -5 and a +2. This has an x in common. I'm going to take the x out. And then down here I'm looking for numbers that will multiply to 6 and add to be 5, so 3 and 2. Then I really get to cancel. This is my favorite part. We just cancel everything that's in common. On the top I'm left with x minus 5, and on the bottom I'm left with x for my solution. The only thing that's different on divide is that if you remember from like 4th, 5th grade math, when we divide by a fraction, we actually multiply by the reciprocal. So we're going to flip that second fraction upside down and multiply instead. So we're going to have 7x over 2x minus 10, and then we'll times by x squared minus 11x plus 30 over top of x squared minus 6x. So we really just flip that second fraction upside down and multiply by it instead. We're going to take a 2 out of the bottom here to have x minus 5. The 7x doesn't do anything. We're just going to leave it as 7x. Up here on the top, I'm finding two numbers that will multiply to 30 and add to 11, so a -6 and a -5. And down here on the bottom, I'm going to take an x out to have x minus 6. Then I just get to cancel. X minus 6s are gone. X minus 5s are gone. This x right here gets to cancel with this x right here. So on the top, I'm left with 7. On the bottom, I'm left with 2. You can turn that into a 3.5 if you'd rather see it that way, or 7/2 is totally fine. Number 10, same thing. Division turns into a multiplication problem by flipping that second part upside down. So we're just going to take a minute and we'll rewrite it with the bottom on the top and the top on the bottom. Then we'll go through and we'll factor. I know I'm moving really fast here. If you need to pause anytime to figure out your factoring, go ahead. The 9x squared is one term. It's by itself. This second one right here has an x in common, so I can have 2x minus 1. Here I can factor out a 3. I'm left with 2x minus 1. And here I can factor out a 3x. I'm left with x minus 4. And then I just cancel everything that can cancel. The 2x minus 1s are gone. If I multiply this back together, I'd have a 9 right there, so I can take this 3 and this 3 and cancel it with that 9 up at the top. I have an x right here that will cancel with that x right there. So on the top, I'm left with x squared, and on the bottom, I'm left with x minus 4. Again, it makes you want to cancel the x with the x squared, but you can't because this x is attached by addition or subtraction. All right, this last problem here, super bonus challenge problem. Really, if we look at this, we'd have x divided by 2 over 3x minus x squared. And then if we wrote it with a divide sign instead, we'd have divided by x squared plus 7x minus 18 over x squared plus 9x. So really, this is not as hard as it looked. All I have to do is flip this second fraction upside down and multiply by it instead. So I'm just going to rewrite it now as a multiply problem by flipping that second part upside down and then just factor. This is already factored, x minus 2. This has an x in common, so I'm going to factor out the x to get x plus 9. This I need to flip around so that x squared is in front. Then I can clearly see that I need to take out a negative x to get x minus 3. And then right here I can go x plus 9, x minus 2. And I just cancel. The x minus 2s are gone. The x plus 9s are gone. This x and one of these x's right here cancel to a -1 because it was a negative on the bottom. So I have a -1 on top left over, and I have an x minus 3 on the bottom for my solution. Good luck with your assignment.